for the edition of Manufacturing Live. My name is John Milbery and I'm your host, and we have some very special guests with us today. We have Trevor Goforth. We also have Barry Setzer. We have Travis Jarrett, and the indomitable Jessie Smith is also with us. So it's my pleasure. You know, this is a trifecta, and so this week, what we're doing today is we're doing Manufacturing Live. Tomorrow we're going to do live design, and on Thursday we're going to do Solidworks Live. So be sure to hit your like button and please subscribe so that you can get, a notification for each of these live sessions. So guys, I'd like to start out with, I've been on your site and I've read all about Titan's story, and it's a fantastic story. And nobody can deny that. I just love it. But one of the things that I want to ask you about today is your story. How did you find your way into manufacturing? Right? I know that when I was like 10 years old and my dad said, "What did you want to be?" I didn't raise my hand and say manufacturing. So there was kind of a story, and I'll bet there's one with you as well. So let's start out with, Travis, let's start out with you.
Yeah, for sure.
Let's go ahead and talk about how you found your way into manufacturing.
Well, I definitely didn't raise my hand and say I wanted to be a manufacturer, right? But I kind of fell into manufacturing kind of by accident, John, really. I kind of, out of high school, I actually went into the military. I did a quick stint in the military. After that, I actually went to school, and I actually, believe it or not, I got a degree in philosophy.
Philosophy?
Right? Yeah, philosophy, yeah. And so for anybody who's graduated with a philosophy degree, you obviously come to the question, well, what do you do with that, right? How do I pay the bills and put food on the table? And so I went to go look for a job, and I started searching, and I saw an ad for a welder, actually. It was a beginning position, intro welder, and I thought, well, I took ROP welding in high school, no machining, but I did a lot of welding. And so I went in and I applied, old school machine shop. They almost didn't hire me because I was overqualified or whatever. I had a college degree, but I think I interviewed well, and they gave me the job, and I went in there. I remember walking down, I walked through the shop. I remember the smell of the oil and the dirt. It brought back all these memories and stuff of my metal shop experience.
Sure.
And I fell in love with it. I remember I had to run this robot arm welder. I remember the sparks flying on. They burned the back of my head. I did heat treatment with these big old blow torches and these sprockets that we'd cool in this coolant. And for me, it was good, honest work. And
yeah.
I really, really fell in love with it. And so for me, that was just kind of how I fell into it. I worked there for about 3 years, and I remember doing a search. I got to the point to where I felt like I had learned what I could there, and I wanted to move on. And I remember doing a search, and I came across this company, Titan America Manufacturing. And so I remember looking at the website. I saw the work they did. I saw the people there. There was kind of a culture that came through on that website, and I told myself, I want to work there. And I remember, I wish I would have saved it, but we had a desk with a whiteboard, and I actually wrote on that whiteboard, I put Titan America MFG. And it took me probably about 9 months, and I think 3 applications, but eventually they called me in, and I got the job. It was about a 45-minute drive. It was longer than I wanted, but I really wanted to work there. And Titan hired me, and the rest is history. I've seen us go through, the manufacturing, the TV show, and now here we are doing a live broadcast with Solidworks, so it's been quite the ride.
Congratulations. I mean, you've got to be working at probably the best manufacturing facility in the United States.
Absolutely an amazing opportunity. Absolutely amazing.
So let's spring over to you, Trevor. Tell me a little bit about how you found your way into manufacturing, because your specialty is really additive, right?
Yeah.
So let's hear your story. Tell me a little bit about yourself.
Okay, yeah, so like you, John, I didn't plan on being in manufacturing either. When I was young, I always wanted to be a professional baseball player, actually, so I had big dreams. But after my last year of high school, I went to a community college on a baseball scholarship to play for their baseball team, and I went to school for physical therapy. That's what I wanted to do. And after that first year, I had an okay baseball season, but I just kind of took an honest assessment of myself and my ability, and I kind of came to the conclusion that I wasn't going to be a professional baseball player. So I went back to my dad and I told him, hey, I don't really like physical therapy, and I don't think I'm going to make it to the pros. I don't know what I want to do. And so we talked about it, and he basically said, well, what if you might like what I do, and I thought about it. I'm like, well, what does my dad do? You know, I mean,
I thought the same thing when I was a kid.
To me, it was always, you know, he went to a shop, he got his hands dirty, he ran some machines, and he came home, and that was basically what I knew about his job. So I started to look into it. I did some digging, and I fell in love with it at that point. And I enrolled in a machine technology program at a community college, and I remember getting my machinist handbook, and I cracked it open, and I was like blown away by how much information was in that book, you know. And I was just like, man, does my dad really know all this stuff, you know? And I was just impressed. And so I looked a little more, and like I said, I just loved it. Loved being able to make something with your hands, you know, something physical. And
sure.
I went to that trade school for about 6 months, and opportunity opened up at the shop that my dad worked at. And so I took that opportunity and went to work full-time at that shop and learned under him for 8 years and the group of guys there.
So you learned underneath your father?
I did, yeah. I got to learn the trade from my dad and all the guys at that shop, and it was an incredible opportunity. Just a great way to break into the trade. So I started in a manufacturing assistant role. And I remember seeing all the beautiful molds and parts that these guys made, and I was like, yeah, I definitely want to do that as a career. You know, it was just super rewarding experience. From there, I moved into a prototype machinist role, did that for about 4 years, learned a lot, and then I was given the opportunity to do an apprenticeship as a mold maker. I took that opportunity as well. I learned EDM, you know, just learned how to really hold tight tolerances. And after that, my wife and I decided we got sick of the rain in Washington, so so then we moved to Texas, and you know, luckily I did that about the same time Titans of CNC moved down here, and yeah, had my interview here, and Titan and I hit it off really well. You know, we believe a lot of the same things in regards to manufacturing, and we both love this industry. So yeah, I got the job, and now I'm just blessed to be here.
Well, that's a fantastic story. I love the part where you spent 8 years under your dad, you know.
Yeah.
That's incredible. Who better to learn a trade from than your own father?
Yeah. I mean, yeah, there could have been some challenges, but you know, he was very patient with me and taught me everything he knows. So.
It's a good dad.
Yeah, oh, he's the best.
There you go. So Jessie, how about if I pick on you for just a moment? Now Jessie, you're from Mississippi, and I know you are not going to hold back. So give me a little bit of background. How did you find your way into manufacturing?
So I was a lot like Trevor, you know, I was the typical senior high school student. I didn't know what I wanted to do with my life because I thought this whole time that I was going to be a professional athlete. All I cared about was football and baseball. So, but at 5'9" and 140 pounds, I realized that wasn't going to take me very far. So I didn't really know what I wanted to do, but I had a grandfather that was an aerospace engineer for NASA. So I was like, you know, that really interested me. And but quickly realized that that really wasn't going to be realistic either. And so I, in the same boat, didn't know what I was going to do. And my mom kind of talked to me. She's like, you should look into being a machinist. Had no idea what it was. I didn't know what anything in manufacturing was. And I loved mathematics, loved science. And she said, well, all I know is you do a lot of math and you put numbers into a machine. And I kind of went to a local community college, kind of like Trevor, playing baseball. Was a redshirt freshman. And so started in this machining program in tool and die, and a friend of mine was in the class, and he had took metal trades in high school.
Yes.
And I remember walking around during orientation, looking at the machine going, what is that? And he's, well, that's a lathe. You do round parts on it. And I was like, oh, cool. Well, what is that? Well, that's a mill. You do square parts. And so that was my knowledge. Like, I knew nothing. And
Okay.
But after our second project was a 50 caliber replica of a 50 cal shell, right?
Mm-hmm.
And instantly fell in love. Taking it from raw stock to something real and something, it was so artistic and just beautiful. And I was like, and just instantly fell in love with it. And actually after my first semester, I realized I was so far behind the curve because I'd never been around this type of stuff that threw in the rag on baseball, kind of give up on that and just immerse myself in this trade. And from there, it was just all day, every day, as much as I could get of it and I just threw myself into it. And
well, that
it's
sounds
been there ever since.
That sounds like a great story, and it is. Tell Tell me a little bit about, you've got some lathe experience, right?
Yeah, so I spent a lot of my career on lathe and mill turns.
Ah, that's excellent. The mill turns are really making a comeback now, right? They're really,
Yeah.
these machines are just so incredible in what they'll do and their flexibility.
What's the best of both worlds? you know?
Yeah, so you're running some of those, I guess some of the Akuma 11 axis
So I
mill
did a lot of
turns?
9-axis. Mazak Intergrex was one that I did a lot of. Akuma Multis, B550, we had one of those, and I even did a DMG Mori
Yeah.
NTX. So yeah, a little bit of everything.
Well, thanks for your story. I mean, that's again another great story about somebody who found their way into manufacturing. Barry, I haven't forgot about you.
Oh, darn the bad luck.
I know, but so Barry, give me a little bit of your story. I mean, obviously, you're in management, you're a machinist.
Yeah, I kind of played the whole gamut. You know, I borrowed a little bit from each of these guys' stories. So my grandfather and my father owned machine shops in Chicago. And so I grew up in their shops from the time I was a kid. You know, I'd help them clean out their chip hoppers, paint forklifts, you know, whatever they needed help with. My grandfather would pay me piecework as a kid to put together some of his products that he sold.
Yeah.
You know, I always said, though, I was never going to be a machinist because it was dirty, you know, rusty. Like, I gravitated more toward the engineering side of things.
Oh.
And so I spent years, you know, as a robot programmer, a year as a quality manager. I did so many different things. You know, I worked as a structural design engineer in aerospace and in automotive.
Really?
Yep. And that was where I kind of got to be in love with Solidworks and what you guys produce, you know. So I gravitated towards that, but I was kind of surprised in the end because, you know, I went and became a full-blown engineer, designer, and it ended up that I missed the machining. There was something about actually touching the parts. You know,
Yes.
you start with this blank slate in space, and pixel by pixel you create this awesome assembly or model. But if you don't get to see it in real life, you're kind of missing that satisfaction that you get in the end.
Yes.
And so now, you know, I'm here at Titans of CNC, and this is the Disney world of manufacturing. You know, I mean, I get to work with the best machines, the best tooling, the best machinists, got the best boss, best software. So, you know, I can't complain with the direction I headed.
I love what you said, the Disneyland of manufacturing. And you look around and you're absolutely right.
Yeah.
It's really an honor to be here today and to be with you guys. I think let's jump back to Trevor for just a moment. Trevor, give me an idea, because we've got your background. Let's take a look at kind of how you do your job today. You know, what does it entail?
Sure.
Talk to me about what you really love about it, and maybe is there somewhere an emotional paycheck?
Yeah, so for me, I guess what I love about my job is I get to work on the cutting edge of kind of a newly developed technology. You know, it's been around for a while, but at this point it's basically still being adopted by a lot of shops, and there's new applications for it every single day, you know. And that's what I get to do, is I get to explore some of those opportunities to showcase an application or a way to utilize 3D printing that might benefit a shop out there in the world somewhere, you know. One of the biggest things, go ahead, John, did you?
Well, I was going to say, something tells me that you like to explore. You like to look out on the horizon. In fact, I bet that's probably true of all four of you.
Absolutely.
Yeah, go right ahead.
Yeah, so you know, what I was going to say is one of the biggest areas that we're trying to explore as kind of a job shop is fixturing. You know, it's a big thing for a lot of shops. They have to spend a lot of time fixturing parts, especially if they're job shops and things like that. And if they can run those fixtures unattended and they can make them in a way that, you know, doesn't constrain them as far as the design goes, you know, that could be a huge benefit for a lot of shops. So we're exploring that every single day. You know, we have new opportunities that come along to explore that application all the time. And that, I think, is my favorite part, you know, being able to help shops compete in that way.
I think that's fantastic. And you know, fixturing is so critical, right? People who actually do the NC programming and people who actually run the machines, a lot of times they're the same person. We forget how critical, right, fixturing really is.
Yeah, You know, I would say that it's probably the best way that shops can separate themselves from each other, and as far as competition goes, you know, if you can figure out a way to fixture something more efficiently than a competitor, you know, you're going to have an upper hand for sure.
Absolutely. One less setup, quicker machining process.
Yeah.
Absolutely. So Travis,
Yes, John.
give me a little bit about your philosophical life
Yeah.
in quality control.
Careful what you ask.
How much time do we have, John? No, I mean, my philosophical life and quality, I guess it makes sense that I would end up the quality manager, right, in some sense. I mean, I think, you know, philosophy plays on the details of things, right, you know, and how these minute features of, you know, morality and life and all these things kind of contribute to this overall whole. I mean, quality kind of does the same thing, right? We bring in this whole part from one of these guys, right? And it has all these minute features that have GD and T attached to it, and tolerances, and they have to work together. And I have to dig into those details and, you know, basically uncover the secrets of the part, if you will, kind of thing, you know? And so for me, I've always kind of enjoyed that. I think you know, manufacturing in general and quality especially just kind of provides that intricacy that I actually got to experience when I did my philosophy degree.
I think that's a great parallel. Tell me a little bit about your GD and T background, because I know that, you know, a lot of people struggle with GD and T, right? It's a life learning process.
It really is, you know, and even I would say that I'm still learning GD and T.
Yeah,
I mean, you still come across
too.
problems
Yeah.
and you're like, all right, let me pull out my, you know, my 14.5 and relook at stuff. But I remember actually, I didn't really see a lot of GD and T until I got really to Titan Shop. I remember our prints were pretty basic and stuff. And I remember getting to Titan Shop and there were medical parts and aerospace parts. And I really kind of had to dive in and be like, well, I had to figure it out on the job. That's how I figured out GD and T.
Really?
Like, I remember, I'll never forget, we were running this face pass on a program and it had a surface finish call out. I'm like, this thing is running so slow, man. I'm going to turn this thing up. And so I ran it faster, and of course it ruined the surface finish on like 8 of these parts. And I'm pretty, it was titanium or Inconel, something really hard. I remember spending hours having that part back in the lathe and just polishing that face down.
Yeah.
So I learned a lot about GD and T the hard way.
We all did.
Yeah, exactly. You know, so GD and T is one of those things that's super important, and I would definitely, you know, recommend spending the time, you know, to invest in that. You can save a lot of costly mistakes, because that's the language of the parts right there.
So, in the training programs here, do you guys touch on GD and T at all?
We would like to and stuff like that. We do, I think, when a lot of our projects come up and stuff like that, we have GD and T incorporated.
Sure.
Obviously, as we go forward, we're always looking for new avenues in which we can continue to educate the people that we serve, which is the wider community out there. And so we definitely want to look to do maybe a little bit more in regards to providing that essential education.
Fantastic. So Jesse, let's move over to you, my man from Mississippi. Tell me a little bit about you know, what really gets you jazzed in your job today? What is there an emotional paycheck for you? What do you love doing?
Oh, definitely. I mean, I've always loved taking a young mind that's eager to learn and teaching them what I know and what I've come to learn, because I remember being that person myself and not having a lot of people to go to. So, and I've always been gravitated to intelligent people. Intelligent people just, you know, fascinate me, and I always try to surround myself with those type of people. And I remember going so many years being so interested in high-speed machining, but nobody around me did it, and nobody could tell me how to do it. I did all this research trying to figure it out, but it was really hard because there wasn't a lot out there.
Yeah.
And people that I would go to about it that I knew personally would try to discourage me from doing it. It's like, oh, we tried it one time, we can't do it. So it's like, I was really discouraged by that, and so that kind of really motivated me to, when I see somebody else that wants to learn, I throw everything I know at trying to teach them what I've come to learn, because it was so hard. And that's something that I really love today and love about this job, is I can take all that I've learned on 5-axis, and I know that there's so many people out there that want to see how I would process a part, or the little things that I've learned about 5-axis and apply it to their life. And for me to be able to share that knowledge is everything.
I can imagine, because it gives you a tremendous sense of payback.
Exactly.
And that emotional paycheck that we talked about just a moment ago. So Barry, What about you? Because you do a little bit of management, right? You do a little bit of, of course you do all the machining as well.
Yep.
Tell me a little bit about the emotional paycheck and what you really love about your job.
So probably the main thing that I love about what we do here is that we've spent our entire lives trying to become the best at what we do. And we have this huge community out there that we can teach all at the same time. You know, we don't have to have a physical school where we have just 50 students. The world is our classroom. And so we can just, you know, sit here, me, you, and, you know, the rest of us guys here, and we can just release a video a day to teach you one little thing that took us our whole career to learn.
Yep.
And
that is so true.
And not only that, but we do it for free. So, you know, we have a free online academy where we can teach people how to use Solidworks, where we can teach people how to program a part, where we can teach you how to machine the part, and it's just out there for you to use, you know, at your will.
Yeah, that's incredible. So you get, you know, you're right. You can spend years learning a little secret trick or a little thing that makes such a big difference in manufacturing, but then in just a moment you can convey that on to others.
Right, yep.
And you watch them move forward with that, you know. A great example of that too would be high-speed machining, you know, that Jessie talked about. You know, gosh, when I first saw the chips come off of that, I was like, ding, ding, the light bulb went on.
Right.
And I was forever hooked.
Well, and if I could say something, John, I mean,
Sure.
kind of touching on that, you know, I mean, if you go to like our Facebook group, you know, it's not only us, like we have motivated a whole group of manufacturers that come together. I mean, sometimes somebody will ask a question, you know, and before we even have time to get on there, there'll be like 40 answers down there. I'm like, I can barely even contribute to this. So, I mean, if you're not on our Facebook group, you should be, because I mean, there is just a wealth of information out there that is really, truly inspiring to see.
But I don't think Barry was completely honest. I think his biggest emotional paycheck is telling me what to do.
I mean, he does all the machining.
He does. He really enjoys that part of his job.
I must confess that I do like that, and that was a condition of my employment with Titans, was that I would be able to tell him what to do.
Sure. So I've got a question from Glenn Shirley. Glenn talks about bending as their entire life and fabrication. But does Titan of CNC work with, you know, any of the bending or fabrication sheet metal?
So at this point, we don't.
Yeah.
But you know, that's kind of the beautiful thing about what we're doing here is it just continues to grow and grow, and eventually we will touch every facet of manufacturing. And we actually work with Trump, so that's who we have. One of our metal 3D printers is with Trump, and they have bending equipment and things like that. So, you know, there's tons of opportunity out there to expand into that for sure. And we don't want to leave anyone behind, you know what I mean? We want to fill every skills gap that there is. So,
Sure.
So that's the whole Titans thing is this is not just what we do is this. We're building.
Yeah.
We are in the middle of building, and he wants to go through, like you said, through every facet of manufacturing and teach the whole industry.
Perfect. We've got another question too. And this one I think is for you, Trevor. How does Titans of CNC practice generative design and subtractive manufacturing?
Generative and subtractive manufacturing.
The generative design.
So, generative design, you know, I don't know. I might have to give this to Barry. I might have
I think Barry saw it coming.
I think he did. Only because I personally just think that he's going to be better at answering that question. I want to make sure that they get a good answer on that.
And that's something that's important to recognize here is that we all have our individual strengths. And I've spent so long in SolidWorks now, and one of the things that we've been finding really interesting for us as a team is that we're not just designing a part now to be manufactured subtractively, but we're designing it with additive in mind. So that means that it opens a whole new realm of what a part's functionality is capable of. So we're reducing weights, we're increasing strengths. Stay tuned because we got more content coming out on that in the near future, but for now we're exploring it in depth.
And that might make a great session too in the future that we can do on generative design.
Yeah, absolutely.
I think so, yeah.
And you know how that is really becoming a hot deal in additive manufacturing.
Well, and that's the thing is it is a huge benefit of additive manufacturing, right? To be able to only add material where you need it.
Correct.
But you know, in terms of how we would handle it as far as subtractive, I would say You know, a lot of generative design parts that I've seen is bracketry. That's like one of the main applications for generative design. And you would basically print that bracket and then finish machine the surfaces that you need to from there. And that's another area where fixturing could come into play. These generative design parts are very complex, you know, so holding them in subtractive manufacturing would be difficult. Maybe you can print your fixturing into that as well.
Sure, I think that is a great perspective and a great idea. So let's switch gears a little bit. It's 2022. You guys are on the cutting edge of technology, and you're exploring that technology every day. Let's talk a little bit about where you see your jobs going in 10 years. I mean, we've got what? We've got Industry 4.0, we've got the Internet of Things, we've got this technology explosion that's occurring, seems like every day. Jesse, what do you think? How do you think your job is going to change maybe in 10 years from now?
So I think there's going to be a lot of responsibility put on manufacturing engineering. I've been seeing that throughout I've been into a lot of different industries. I've been in automotive industry, medical devices, defense industry, and from what I have seen is the industry's going in the direction that suits them, right, and suits that particular thing, and there's different problems for different industries, and something that is a huge problem is the skills gap. And not only the skills gap is getting people to work, period. And it's a sad truth, but it is what it is. And technology is being pushed by that. And that's why you're seeing a lot of automation. So I think obviously in the future, automation is a huge thing, but it's extremely expensive. And what's going to happen is that's going to create different types of jobs and a different type of skill.
I see.
And I see a lot of the future becoming that and becoming more of a smaller group of critical thinkers and a bigger group of operators and things like that.
Machine technology.
Right.
Okay, that's fantastic. So I think you're right. I think that's the way it is trending, and that's what we see out there in the world today. Travis, what about you? Tell me a little bit about some of the advances that you think are going to occur in the quality area over the next 10 years.
Well, for sure. I think Jesse pegged a lot of it. I think you will see a lot of industrial engineering, right? System architects and stuff like that. I know I've seen a couple articles about how, I mean, they're already working on softwares that program parts. I know that we have quality software that is working on writing, basically, you know, baking the GD&T into the model, right? And then you load that, and it will basically take your whole rack of probes and it will begin to create that part for you. You know, and so it might become more incumbent upon a quality manager to look at the overall process. How do we make sure the parts are in the right place at the right time? How does setup take place, you know, right before the part's going to arrive? Sort of this just-in-time concept, but almost, regarding the flow of manufacturing goods. I think a lot of that's going to require a lot of data, right? And that's why you talk about Industry 4.0, you know, and there's going to be a big, I think, heavy reliance on big data, how to capture it, how to analyze it, and how to use it, you know, in an efficient manner.
So basically, you're talking a little bit about artificial intelligence.
There's definitely going to be some of that involved, absolutely. It's got to be able to handle large amounts of data. You know? The days of, you know, writing your program times on a piece of paper at the machine and stuff like that probably will be a thing of the past.
Sure. Yep. Exactly. So Barry, how do you see things changing in 10 years? You know, we talked a little bit about artificial intelligence and some of the other things. What do you see on the horizon?
First, I want to add a little bit to what Jesse said about the skills gap. Because, you know, everybody talks about it, but nobody really does anything about it. And so I was talking to somebody earlier today about a kid that we have here who just came in fresh from high school with 0 experience. And within his first 10 days working here, he was able to go through our entire building blocks series, designed everything in SolidWorks, programmed everything in Mastercam, and then came out here to the machine and actually machined the parts. Now that's within 10 days of him having ever seen a CNC machine or the software. So I think that speaks a lot to what Titan is built in order to help address the skills gap. Now, when it comes to the future of things, I'm reminded of when I went from 3-axis programming to 5-axis programming. Everybody told me it was going to be so much harder, and you know, I might not even be smart enough to do it. But then once I wrapped my head around it, I realized it gave me freedom. So now I didn't have to waste time trying to figure out, 6 different operations and all these different fixtures.
Right.
I could just dovetail my stock, throw it in the machine, and then attack the whole thing. And I think we're going to see a lot more of that as AI starts getting involved, as softwares start getting better and stronger, and computing power gets greater. And I really look forward to seeing what gets easier for me on a day-to-day basis.
Sure, sure. And I think that's a great point that you make, that artificial intelligence and the way things are done in 5-axis are going to start to come together. And we're going to start to see when you can sit there and attack or machine all 5 different sides of a block, your setups are going to be definitely limited, right? You're going to compress that amount of time that it takes to go through the shop.
Especially now with the equipment that actually combines additive and subtractive. So you have a 5-axis mill that's printing your part, and then it can tell when it's messed up a layer, come in, cut that layer off, reprint it. It can machine features as it's printing, so ports and things like that.
Wow,
so it's just incredible technology that's just in its infancy right now. And as we start to see it become more and more used in the industry, I think all of our minds are going to be blown.
Sometimes feels like, like we'll tell our grandkids we used to cut chips, or something like that.
I will always cut chips.
So, Trevor, can you expand a little bit, that hybrid machine that we're just talking about?
Yeah, absolutely. I mean, it's essentially the best of both worlds, right? I mean, to be able to add material where you might have a curved internal port or something like that, but then, come in and finish machine that face without even having to change setups or move it to a new machine or anything like that. I mean, it could be incredibly useful for a lot of companies out there. I think the future of manufacturing is very hard to predict, looking at how far we've come in the last 10 years. I mean, it's been a huge jump, right? But as far as additive goes, I look at a lot of opportunities in like DED 3D printing, where you can come in and you might have a huge part that you spent a lot of time manufacturing, and it might need to be repaired in a small spot. But you don't want to have to scrap that whole part. You want to be able to come in and efficiently add material where you need it, finish machine it, do things like that. It's just going to make us more competitive as a whole. And then, the companies that are willing to adopt some of these new technologies and willing to change their old school methodology and things like that as things progress, I think that they're going to have the competitive advantage over everyone else, and they're going to be more fun places to go to work. So they're also going to attract better talent, because they're pushing the envelope. They're willing to adopt new methods and new ways of doing things to propel their company to the next level. Sure,
it's an upward spiral that just basically floats everybody upward, makes them better. We have a couple of questions. I've got one from Mohammed Al-Badal, and
commenter.
He wants to know if you have to learn several specialties at the same time. In other words, you have to learn grinding, turning, milling, and EDM all at the same time, or should you have a clear specialization or 2 at the maximum when you first start out?
If I may jump in on that real quick, guys, that was actually one thing I meant to talk about in the future, manufacturing, that I kind of forgot to, but I think we will see that as a lot of people going into one specialty, because there is so much involved in running these 5-axis machines, or in running industrial 3D printers and things like that. So I think that is one thing that we will see, is people branching off into a single specialty. As far as choosing what you want your specialty to be, I think it comes down to passion. What are you passionate about the most? Do you like running 5-axis machines because you like that simultaneous 5-axis milling, or maybe you like making incredibly intricate and precise parts, so you might like EDM, cutting carbide, things like that, or the possibilities are really endless with additive, so maybe you want to specialize in that.
Yeah, maybe you like sitting in 68 degrees Fahrenheit all day long. I mean, maybe
there is a benefit to
but
that.
I think there's also something to be said for both ways, because as we talk about the way we're combining machinery now, we're having additive machines combined with 5-axis mills, combined with turning. So in cases like that, it's better if you have a wide range of specialties, where at other places it may be better if you have a single specialty. So it kind of depends on your personality and where you're working at and what you're hoping to accomplish. So
I think that's a great point you make, Barry. So I've got another question here from Stephen Biggs. Stephen, I'm gonna address this to the entire group. The trend is always the bottom line. So the focus is on efficiency. We talked about efficiency today. Is it better to set up multiple parts in one build or run singles?
So it depends on what you're doing.
In my opinion, it's always better to run multiple parts.
Yep.
The problem comes in with all the just-in-time delivery and things, you know.
Right.
The push of managers and companies that I've always worked for has been just to make exactly how many you need and then switch over. So the key then becomes making your setups more efficient. So rather than just, you know, popping vices in and off the table, you want to have modular fixturing systems. That's why we're big fans of the shunt stuff, the pull stud style mounting, because it does make your fixturing quick change.
Right.
So
the modular fixturing, that is it's so important today. What type of tolerances can you get on that type of modular fixturing when, you know, how close can you come when you change over?
a tenth or two.
A tenth or two of a thousandth.
Yes.
When you talk about the future of manufacturing, and I think you're right. I mean, the more versatile you can be, right, and the quicker you can go from one thing to the next is really going to, you know, put you in the next level of that top tier manufacturer.
Well, if the spindle's not turning, the company's not making any money.
Exactly.
So you've got to keep that spindle going. But, you know, that's a kind of a loaded question too. I think it's a part by part basis, because if you got multiple parts that have a secondary operation, and that program is a very long program, well, then you got 4 parts sitting there inside the machine that you can't do another operation on until they're all done.
Right.
So, you know, or if it's a very quick operation, yeah, you get all 4 of them, you get them done, or if that's the only operation they have, you know, so I think it becomes a part-to-part basis. You have to think about that.
Right.
I absolutely agree. In fact, I'm reminded of a part that Jessie was doing that had such an intensive fixturing setup that they wanted him to just make one part, but it was going to cost like a week, you know, to have to remake all the fixtures for each subsequent part. So, case by case.
What did you wind up doing? Did you just make one part, or did you make a couple?
I don't remember.
Which part was it?
Sub,
Yeah, so
or maybe it was the columns on it.
yeah, there's certain things like when you get into super tight tolerance parts, that's a whole nother ball game.
Yes.
You know, and it's like you got to design the fixturing in a way that it's going to repeat, but if you take it off, put it back on, is the fixture even going to be repeat, or you're going to have to machine it again, you know, requalify surfaces, and that's another thing you have to think about in the process of making your part. And so something our managers wanted us to make one part complete all the way through. It's got 5 operations. Make one part all the way through, make the next part all the way through, because it's got other places it has to go. But we tried to explain that's a very hard thing to do, because every time I take it off to set up the next setup, I've got to requalify those surfaces, and you're going to have to do that for every single part. Instead, let me make operation 1 on 4 parts, then operation 2 on 4 parts, operation and so forth, because you're drastically reducing your setup time at that point.
Right,
where
right.
Instead of 8 hours per part, you're reducing it to 8 hours for 4 parts.
Right.
You know.
When you requalify these fixtures, are you using probing technology to do that?
If I can, I can.
Okay, absolutely. So I've got one here that's kind of interesting. It might be for mechanical engineer, but I'm going to throw it at you guys. How can we choose the right metal for the right application, but in the easiest way?
That is a very good question.
Yeah.
That is a tough one.
I mean, it
Especially
would
if
be
you
based
don't
on the
have a
requirements of your
metallurgist
part,
or,
right? I mean, there's a lot of
yeah.
questions.
I mean,
You kind
it's
of have to know the finish environment that your part's going to be in, right, and what it's going to be used for.
Is this a jet engine part, you know, sub-C part?
Right.
You know?
We kind of have the luxury of having that kind of stuff decided for us when we get the job, typically. Now, we can obviously kind of assist and lean on some of our experiences, but yeah, I would have to say, I mean, it just all depends on the application of the part. You know, without knowing that, it's difficult to
Right,
It
choose.
is definitely about a level, because, you know,
Right.
when I was at my first job shop, they did that a lot. It's like, well, I need this made. What do you think I need to make it out of? Well, Well, I'm not a metallurgist, but I can tell you right now, I love machining 4140s. So you're probably going to get it out of 4140.
I can move that aluminum around really easy.
We'll see how that goes.
I guess the best answer would be the easiest to machine and the cheapest that will still work.
Yeah, and that really depends on the application. Of course, a lot of engineers are going to run finite element analysis on it, right? They're going to load it up and they're going to find out where it breaks. They're going to build in a factor of safety.
Exactly.
So there's a little bit of a, I guess, engineering portion to that as well.
Big time.
So I've got a good one here. You guys are so far ahead in machining, education. How do you keep up with coming out with new ways to push the envelope without burning out? You know, how do you find the next great, best way to educate, to take what you know and to pass it on?
Taking what I think is cool and then doing it on camera.
There we have it.
Full slotting at 100 inches a minute, you know, balls and boxes. Just, we all come up with ideas all day long of what we can teach by showing you a certain piece of content. So we're always working on that.
One thing I would say is for me, it comes down to problem solving, right? That's the beautiful thing about being a part of a growing community of people out in the real world making real parts is they run across problems. And so if they share those with us or we see them struggling with something, you know, we might be able to take that and say, okay, we can develop some resources to helping them, you know, helping them try to find a solution to their problem or a way to do it better. That's, I think, the most valuable thing that we can do is help people out there solve the problems that they're running into in the real world. So if any of you guys are ever watching our channel and you have something you're struggling with, feel free to reach out to any one of us, comment down in the comments section below, and we'll do our best to help you guys out. So.
And I think that's part of the emotional paycheck that we talked about earlier. You know, and that's just fantastic.
Something like that is what's wonderful about machining as far as the teaching aspect is, what I've always liked is that you can give the same part to 10 people and you will have 10 different processes.
Yes.
So that really keeps this interesting, and as far as teaching, it's like, well, I might come up with something to teach somebody and it might not, and when Barry sees the video or the part in Solidworks, he may have processed it differently, but it's okay that I show it the way I want it to, because it gives somebody a different perspective and gives somebody a different idea that they may have not have thought about before. Just like a video that I just recently done on chain drilling.
Okay.
For a very tight pocket, like you come up with, you know, it's how to get that material out without breaking my tools. Some people might have not have thought about chain drilling before, and some people might have just roughed their way through it and tried to get through it the best they could. Well,
can you explain chain drilling for the audience?
So yeah, so chain drilling is when you know, I have a thin pocket or something that's close to the diameter of the drill, and I go in, I drill a hole, I skip over enough to where I get a full size hole each time, and then I come back and drill in between, the space in between those drills. So basically you're removing all the material with your drill, and there's a very fast, efficient way to remove material.
Excellent.
I like what Titan calls it is, what we offer is a manufacturing red pill. So we're waking everybody up to the possibilities that are out there.
Exactly.
There you go.
Yep.
Yeah, there's
So
not
our
just
way,
one way to do it.
Yeah,
Yes.
what I show you may not be the best way, but it'll get you thinking about somehow you could process the parts that you're trying to make.
Well, and I think that's an important thing, is that we can all use our imaginations are stretched as we figure out how to process plan these parts and bring them through the shop in the most efficient manner. I love process planning for that very reason, because it includes fixturing, because it includes process optimization, because you have to take into account the tolerances for the machines, right? One of these machines over here may be a 1,000th tolerant machine. Another one may be a 10th. But you know each one, what their tolerances are, don't you?
Well, additive manufacturing is a very good example of that. It's
Sure.
like, here's the technology. Somebody out there is going to look at it and say, I bet I could do this with that nobody else thought of.
Yes.
So it's up to the user to see that and see the vision of how to apply it.
And you know, that's so interesting, because as a software developer here at Solidworks, we go out to customers all the time and we go, I cannot believe that you're doing this with our software. We never thought of that.
Yeah.
And so it's just, it's always mind-blowing.
It's almost like we're not so much about providing answers as possibilities sometimes, you know,
Yeah.
that kind of thing. And this is a real
that's what's another-
collaborative environment,
Yes.
you know.
Yeah.
And so,
Right, and that's another thing that's the beauty about manufacturing is you get to see how somebody else's mind works.
yeah.
So, Travis, this one I'm going to ask you. This comes from the audience. And how can designers help programmers to do designs for complete units with little scrap percentage?
Well, I must say we actually have a pretty good video that Barry did on that, on designing for you know, parts.
Manufacturing.
Yeah, parts being able to manufacturability, right, and making sure that you're not using, you know, tools that create, you know, features that are, I mean, from my standpoint, like impossible to inspect, right?
And
I mean,
super expensive.
Super expensive, exactly. Like in that video Barry did, I mean, a small tooling difference can shave hours off your manufacturing process, your setup process, your inspection process, you know. So I mean, at least from my understanding of it, I think, you know, taking a big picture view and really keeping in mind not only what you have to do, but what everybody in that manufacturing process has to do down the line will probably go a long ways in making sure you design correctly.
Sure.
Well, I just want to give that person a hug, whoever asked that question. Just for asking that question is a huge step.
Yeah.
That is
Over tolerancing things. You know, I've seen people put a 2/1000th tolerance on a counterboard hole for a set screw or
Oh my
for
gosh.
a screw, and it's like,
It's crazy.
why? And
True
they don't
position
understand.
2000.
Yeah, and they don't understand that the tighter the tolerance, the more expensive that part's going to be because we
Right.
got to slow down.
What do you guys think about, you know, the solid modelers like Solidworks that can fillet everything? You know, do you ever get those parts where everything's filleted on it and you go, well, we can build this part if you want, but it's going to be very expensive.
Right.
Yeah.
Or we could just remove some of the fillets. You guys run into that?
All the time.
Do you?
All the time. And you know, you can't blame a designer for it either because they don't understand machining, you know,
Right.
processes most of the time. But that's why we felt like it was important to put that video out, because it was about the 3 most common things that we see as machinists that are adding cost to your parts. So, you know, if you're putting a big giant fillet in the floor of a part or fillets around the outside edges of your pocket, these are all things that have to be surface machined, and they could add hours to your part.
Got to use a corner round or whatever. To get
Depths of pockets is another big one in relationship to the wall fillets. You know, it's all about process stability, right? When you start talking about reducing scrap. So, you know, if you have to use these super long tools, you're going to get like super inconsistent results. You know, tool might work through one pocket, but then it might break in the second one. Boom, you got a scrap part. So the more that you can, you know, constrain yourself to some simple rules in part design, I think that you'll go leaps and bounds in reducing scrap rates.
You know, there's some great statements there. So I've got another question. This one is from Timothy Kraft. And Timothy asks,
Tim?
any recommendations for smaller shop owners to prepare for all this new technology that's coming on the horizon? You know, any advice to stay competitive and to stay in the game would be greatly appreciated.
So just trying to find, to doing your research to find out what that new technology is the first step. Because so many shops will take what they have and then just close their doors, and then that's all they know.
Yeah,
and they don't
it's
look
working.
out.
It's working.
Yeah, don't touch it.
Don't touch it.
Yeah, so and it's like, well, now your competitor that's opened up down the street found out a way to machine this part in half the time, and then you're stuck wondering how.
Exactly.
And that is
And
the first step.
you're playing catch up.
Right.
I think also when it comes to introducing technology, it can be a little overwhelming sometimes, right? There's so many areas you can introduce this advanced technology, and I think sometimes, you know, if you look at your pain points, your bottlenecks, right? And look at your bottlenecks, and that's where you look to upgrade and improve your technology, right? You don't have to do it all at once. You know, sometimes people get overwhelmed and be like, oh, well, I can't connect all my machines to some central database, you know, so I'm not going to do it. But look at where you're having the most struggle and start there. And go slowly but surely.
And you fix one problem at a time.
Because you don't want to waste money on the wrong technology.
Exactly.
Something that your shop didn't need.
Exactly.
So this one comes from Ahmed, and finally he says, you know, if you have a 15-year-old son, will you take him with you to the workshop? And what will you begin to teach him at the very beginning of any training that you would do if you brought him here to the workshop? what would be the first thing you would teach them? Maybe safety is one?
Safety would be a good one.
As a
for sure.
necessity, safety would be good.
Yeah.
Respect
the
for the
machine.
machines.
Respect the
yeah.
machine,
Respect
absolutely.
the machines.
Yep. The minute you lose respect for the machine, you could get hurt for sure. But you know, as far as that goes, I would say fundamentals. Just fundamentals as far as design, I think is a great spot to start. Just teaching them how to create something on a computer and then seeing the whole process take place, I think, has always given someone a great place to start.
Sure.
You make the part in design, you program the part, or if you're on a manual, you know, you have them make it on a manual machine. But seeing the whole process all the way through, from the design to the setup to the actual physical making of the part, gives them a good idea of the entire process, and then it's also a very rewarding experience. You know, you go from nothing to maybe, and like the ball in the box is a great example. You know, honestly, that's a really good project for someone who's learning and getting interest in the trade, you know.
And I think that's what makes all of you special, is that you can do the design and you can then come out here and actually put that design on the shop floor.
Yeah, and
So not a lot of people can do that.
I think that's part of the awesomeness too of our academy, is that, you know, you get to go through each of those steps. You get to decide which one maybe you might gravitate towards more.
Sure.
And you know, maybe you like the design side, maybe you like the programming side, maybe you like the actual making the part. But it gives you those 4 spots to kind of start from. And I think that's a really effective way of getting somebody interested in the trade. Because who doesn't like making something awesome out of a chunk of metal? It's super cool.
I wouldn't know. I mean, everybody loves that.
As far as
Everyone I
know.
So this one's over to you, Trevor. How do you see 3D printers? Will they ever evolve as kind of a mass production machine? Will they ever get fast enough to do that, where it makes more sense to do it maybe on a metal printer?
Yeah, I mean, I think it all depends on the part. The part is a huge part of that, you know. I don't think you really want to reinvent the wheel as far as, you know, making parts with maybe more simple geometry or more simple to machine materials. You know, you can make, like Swiss machining, I mean, you can make little aluminum hubs in 20-second cycle times, you know. So it depends on what you're trying to do, but if you're printing very difficult to machine metals and you have a part that, you know, makes sense from a design perspective, there's already people that are printing production in a wide variety of different applications. And it really comes down to, you kind of have to scale in a way where you have more machines, you know, but it's definitely a viable option. So,
you know, one of the things that 3D printing gives you is that design freedom. You don't have to worry about how to fixture it a lot of times. It just lets you think completely out of the normal ballpark, right? So we've got a question about the maturation. We touched on this a little while ago of AI. And I think that you guys have already kind of answered this, but let's retouch on it. You think that the professional machinists will have low demand, as engineers will be able to do the work directly, you know, affecting hybrid manufacturing and using artificial intelligence to connect from their designs directly to the machines?
I don't know if I'd say low demand. I would say maybe a different demand.
A different,
as it kind of comes
that's what we
out a
talked
little bit.
about.
But I mean, I think there's always going to be something to be said for boots on the floor, so to speak, right? You know, I mean, you always have a design stage and you have an implementation stage, you know, and being able to sort of be familiar and integrated with that implementation stage, I think is still going to be important for a long time, and that's going to be where your machinists come in. Even if that role looks a little bit different, I still think they'll have an integral role.
Yeah, because somebody's got to implement it, and,
Yeah,
and the
exactly.
company is going to lean heavily on the people that have machining knowledge
Exactly.
to implement that for them, and then to manage it.
Yeah, you want to make sure that that higher up AI, you know, procedure is doing what it's supposed to do, and your machinists are going to be the ones who know what that looks like.
Right. So we touched on a little bit about big data, right, and AI. Let's take that a step forward. What can we gain from having all the feedback from our machines? You know, processing that live data, sending it to AI. What is to be gained from that? Is there? Give me your thoughts on that.
I think just efficiency, really. I mean, you'll be able to tell. I mean, if you switch from an end mill that has, you know, an Al-10 coating to a different type of coating or something like that, you'll be able to track that data and see what that does you know, with
Over the
respect
long-
to tool life or run
Sure.
time, you know. I mean, I think you'll be able to incrementally, you know, fine tune the machining process, you know, and be able to track it. I mean, sometimes you're making thousands of parts, right? So from just a operator on the floor, it's really hard to tell whether or not any real efficiency gains were made. I think AI will be able to find those small details that when taken in the aggregate will have big results.
Because, yeah, and I worked for a large company one time that it wasn't really AI, but they were getting into a lot of stuff, like a lot of monitoring systems. And they really had to analyze that data because your thought of why you're getting a bottleneck may be completely different from what the reality is.
Sure.
You know, because your perspective can be completely different. And analyzing that data correctly is a big thing. And like you said, the bottleneck, it's really going to show what your true bottlenecks are and where your true inefficiencies are.
You know, and that's a great segue to something else as well. What about factory floor simulation? Do you see that playing a bigger role here where we can actually, let's say on a manufacturing cell, right? We've got a dedicated product. We can simulate robots and we can simulate our layouts well before we actually commit on the shop floor. You see that being important here in the future?
Oh, yeah.
Absolutely.
Yeah, and I think
absolutely.
too, at the same time, you know, when it comes to a lot of software, what you get out of it is only as good as what you put into it.
That's a great point.
So, you know, I've seen a lot of big companies that invested heavily in things like that, but then they didn't end up using it to its full potential.
Yeah.
Now, if you're using it to its full potential, then yeah, it's going to make your efficiency, you know, 10 times better than it would have been otherwise. But you got to make sure that, like the whole analyzing the data from these softwares, you know, your engineers aren't data scientists. So you have to have somebody who's capable of interpreting the results in a way that's going to make changes for your processes.
I think that kind of goes to seeing, you know, the future of manufacturing again, what jobs in manufacturing will look like. You'll probably see more data analysts and stuff like that become required by the manufacturing industry.
Or maybe more AI that will process those results for you.
Sure, sure. So the big data is definitely going to have a big difference, I think, in the future. But again, we're going to need people to analyze that. We're going to need AI to analyze that and to come back with some suggestions. What is, and I've noticed that when I was on your website, one of the things that I loved, especially being from Texas, was all the hard exotic metals that you cut. Tell me a little bit about that. I know that growing up I was cutting a lot of Incaloy 925, a lot of Mon 500, a lot of heat treated, you know, 4140 that goes down well into an oil well. What? Tell me what gets your, you know, stainless steel. Tell me a little bit about how you go about addressing these really hard materials, and is there a kind of technology that you use that stands out as far as tooling and maybe, you know, torqueoidal machining or whatever? Anyone want to comment on that?
Yeah.
I think the things that made the biggest difference for me were multiple fluid end mills, high feed mills, and dynamic machining. So those things all combined.
I noticed that you've got like some end mills that have five teeth on them, and some of them
We've got some here that have 20.
that have 20.
Yeah.
Okay, yeah.
Yeah.
I bought a couple for aluminum, and I tell you what, they were fantastic.
Oh, that must be the Core 5.
Yes, I fell in love with them.
Oh, yeah.
They're
Yeah, they are an
fantastic,
awesome tool.
fantastic end mills. So
There's three aspects of success on that. I mean, it's your tooling, your process, and your fixturing.
yes,
And when you're talking about exotic metals and difficult to machine materials, all three are very important instead of just one or two.
right.
Some stuff is more forgiving.
That's also one thing that we do too, is we provide the feeds and speeds that we're running on these tools, which
Yes.
can be very beneficial to someone, right? I mean, we've literally had people that are machining 316L stainless, and they're like, man, I was taking, you know, an hour to rough out this pocket. I plugged your guys' feeds and speeds in there, you know, your depth of cut, things like that, and it cut my cycle time by 20%, you know, so that's part of the benefit to what we do here, and it's very gratifying for us to hear those things. So
Yeah, and I was just so interested in watching you machine all these, you know, exotic, high temperature, very hard, high nickel concentration material. And it looks like you guys do a great job with it. I mean, I was very, very, very impressed. So we got a question here. What's the best way to get accurate, clean surfaces with less time in processing? So do you have anything that you've got to get perfectly clean on the surface? And how do you go about doing that?
Perfectly clean in terms of if you wanted to inspect something or measure something, or?
I mean, I guess it depends on what you mean by perfectly clean, but you know, Jessie talks about tooling, process, and all these factors that go into it. I think it would probably depend on the context a little bit and what you're doing.
Right.
You know, and
It definitely does. I mean, if you're talking about just having a good surface finish, then it's all tooling and process.
Right.
You know,
Feed rate,
yeah. I mean,
tool nose radius.
And not letting debris get everywhere.
right.
Do you guys have a special process you use to degrease parts, to clean parts?
We don't here. I've been a part of companies that did have like dedicated wash stations. Like they literally they passivate, they wash, they do whole processes, especially in the medical device industry. That's a very, like you have a whole department dedicated to that. Just like you have a whole department dedicated to hand finishing. They hand finish everything.
Yes.
It probably comes down to kind of exploring different, methods, right? I mean, like I've been a part of cleaning processes as well in past jobs, and you might start with a degreaser after it comes off the machine, then you might go into some alcohol, ultrasonic baths. We use those from time to time.
Okay.
So it's probably just a kind of an experimentation process, figuring out what works in the end. So
Perfect. So, any advice on creating a culture in a manufacturing shop to have fun along with the serious stuff? Teamwork approach, I see that already, but comment on it, because to me, one of the most critical things that I took away from being in a machine shop was camaraderie.
yeah.
Absolutely.
Camaraderie was number one.
100%.
Absolutely, yep.
Tell me a little bit about that, how it binds people together for life.
Well, I mean, you spend most of your waking hours in where you work, right? I mean, that's where you spend most of your time. So camaraderie is huge. You got to be able to joke. I think it's important to find people who are passionate about the industry. I think that goes a long way. I know everybody here loves what we do, and I think that goes a long way towards creating that sort of culture where, we come in and we do what we love, and I think that matters a lot.
Right.
And I think that gets neglected a lot in shops because people's just trying to keep their head above water, but they need to understand, I mean, the age-old saying, one bad apple can ruin the bunch, and it's very true. Is you've got one person that's spreading a bunch of drama and planting bad seeds, and it can really bring down your morale in your shop, and you've got to get that person away from your guys. And that's something that we really like here, is that we have got such a good team, and everybody gets along so well, and the culture here is just amazing. And I've been a part of shops where the culture was terrible, and
Really?
you just,
Same, yeah.
as a person that don't want to be around that, all you can think every day is just, I got to get out of here.
Yep, in and out.
It's not a good place to be.
For me, it kind of starts at the top. That's one, I think that is probably Titan's best quality, is he is an incredible leader. I've been a part of shops where the leadership tends to kind of lead from the back, where they're maybe not quite pulling their weight, but they're definitely making sure that you're doing more than is expected of you, and so that can be, after a while, guys kind of take notice of that, right? They're like, well, wait a second, you're not as motivated as you expect me to be, right? And it's kind of can be detrimental to the culture. But as far as Titan goes, like, that guy's up at 5 a.m. in the morning, he starts his day, and we get texts on Sunday like, it's going to be a great week, we're going to change the world, we're going to solve so many problems, help all these people, and he lets us be a part of his vision. I know that's another thing that's huge, is vision. He has a great vision for growing what we do here and helping others, and he lets us be a part of that. So
That's true, yeah. You got to have a leader, not a boss.
Yeah,
He's a very
exactly.
good leader.
Exactly.
Well, it sounds like, and I know for a fact that he is a fantastic leader, especially a visionary. What do you, if Titan was here today, what do you think he would say about what he's going to see in the next 10 years here in this shop? What type of technologies is he talking about bringing in?
I would love to hear the answer.
Yeah,
Would you?
to that.
Because it affects all of you, right?
it's going to be huge.
It's going to be
Yeah.
huge,
Yeah.
awesome.
Yep.
It's going to be amazing, you know. And so I think growth, right? Growth is the idea. You know, we talk about tackling
Sure.
different sectors and whatnot, and I think, you know, the world is our stage right now. We're going to take it as big as we possibly can with the latest and greatest technology that there is, you know. And so
I think that's a great answer.
Yeah. I think he essentially wants to make sure that anyone out there that wants to enter into manufacturing has the resources at their hands to be able to learn everything they need to know to be able to provide for their families, you know. That's his vision. He wants to give people the opportunity to learn for free and then take what they've learned and go and provide for their families and have a fruitful career.
Yeah.
So
manufacturing, giving back.
Yeah,
you know?
yeah,
That's
exactly.
an incredible emotional paycheck right there to be able to do
And
that.
then to not only build the academy itself, but then to build the forums and our Facebook groups
Yeah.
and things
Right.
so that we can continue to support these people personally, you know, throughout their whole journey is incredible.
Great.
Community
Creates
is
a
such a
huge
big,
connection.
Oh, totally,
community is
man.
such a big thing. It's such a big part of what we do.
It is, yeah. So do you guys spend, how much time do you guys spend on the community each day?
Oh,
This
man,
one,
we're-
sorry to just throw that question at you.
6 hours
yeah, I was
minimum,
gonna say,
maybe.
yeah, I mean,
Really?
it's
Quite
quite
a bit.
engaging stuff. We jump on the
It's-
groups and answer comments, and we want to make sure that we are doing this for, you know, the community out there, and we want to be engaged and know that we're here to help you solve real manufacturing problems. And so that takes investment, and it's investment that we're happy to give. So.
And I know I would say that each one of us, we don't look at it as, oh, you know, we have to spend this time,
Yeah.
you know, doing this thing. It's like, that's what we like to do. You know, we like to help others, and we are passionate about what we do, and we like helping to provide answers for people who are also passionate. So we spend as much time as we need to, really, I guess would be the answer.
Yep, exactly.
And that's why most of the people that ask questions today, we knew them by name already.
Yeah, I know. I noticed
Yeah.
that. So that's really great. I've got kind of a different type of question here. I've had somebody ask quite a few questions about simulation, about finite element analysis, and can you guys tell me, do you use any FEA at all? Any ability to do a design study or anything when you design your own parts, or is most of the parts you're getting already done and designed, and you're doing the manufacturing?
Yeah, I mean, traditionally we've been kind of more on the manufacturing side of things
Okay.
and stuff like that, you know. So that's kind of where our, you know, bread and butter came from, and we made parts for, you know, medical and aerospace and
Right,
stuff like that.
right.
So that's where the bulk of our experience comes from, is dealing with these big companies making these high-end parts.
Yeah, and they're already running finite element analysis
yeah,
and doing
exactly.
all sorts of computer simulations.
But that is one of the biggest benefits about additive manufacturing is time to market. So you might hear a lot of people in additive talk about time to market. You know, say you needed a heat sink for an application.
Sure.
You know, you can use a tool like SolidWorks. You can design a bunch of different heat sinks. You can run the analysis on all of them, and then you can print, you know, a few different ones that you might want to print. And you'll have your prototype, you know, whereas it could have been potentially more difficult, you know, 10 years ago if you didn't have those tools at your fingertips. So all
Right.
this stuff, you know, will help manufacturing as a whole become more efficient in the future.
Excellent. So here's another question that we've got. How can you deal with mistakes that happen with you at work? And I don't mean direct dealing, but dealing with yourself psychologically when problems come up, not to get down, but to stay positive and stay focused. Is there any tricks that you guys use to do that?
Fix it and move on.
Yeah,
Fix it and move
yeah.
on. So leave it behind.
Yep.
You got to embrace failure. You know, I mean,
Yeah.
manufacturing is going to involve levels of failure. The most important thing is that, you know, you look at what happened, you learn how to prevent it in the future, and then like Barry said, you let it go and go forward. Failure is a part of the game. Embrace it, let it make you better, and move forward.
And that's what kind of shows that person will be a good machinist one day, or a good employee, or whatever. Because every good machinist I've ever been around, when they scrap a part, they're sick to their stomach.
Yep.
Yeah.
You know, they want to go home like they are upset. And the people that don't get upset over that, you're
They're a
probably not
problem.
going to be in this field for very much longer.
True story.
Yeah, and especially if you keep making scrap, managers, they don't like that.
Right. But it's important to know that
they
if you're not
personally-
scrapping something, you're probably not learning anything. And
Right.
to a certain extent, but it's a very important to take that as a learning opportunity and not a beat myself up opportunity.
Right, right. So here's another question for you. I noticed that there's a lot of different styles of programming as far as pushing the tool to its max. I've had NC programmers that would push a tool to the max all the time, and the operators would always be changing out the tools, right? And I've had others that said, you know what, it takes longer to change out the tools and get everything rerunning again if I would just kind of take a medium approach rather than just a super quick. Can anybody comment on that? What are your experiences with that?
I've had a lot of experience.
Yeah, but both directions, you know, I mean, I think there's a happy medium.
There is.
So you have to know what your tooling is capable of, and that's why it's kind of a nice thing, what, you know, the service we're providing for you guys, because we'll take a tool, tell you exactly what part number the tool is, tell you exactly how we're running it, and what cutting parameters we're using and what material, so you know what the tool can do. And you know, we're not getting out there and pushing the tool to 100% of what it's able to do.
Right.
We're backing off some so that we know it's safe for you guys to use at home.
But that's really a good point. It's like, if you got one part to make, there's no sense in running it to its absolute max. Where if you're in a machine shop of production and chasing seconds is your thing, then yeah, that's the part you need to analyze. Does changing the tool out slow me down, or does running it faster slow me down or speed me up? But that's where redundant tooling comes in. You know, there's different processes for that. Okay, I know I got to change this tool out. It takes me a long time to do that. Let's set up a redundant tool to keep going while I change this one out, put it back in, and you never lose that downtime. So there's other tricks that you can learn to compensate even for that.
Absolutely.
Well, gentlemen, I want to tell you it's been a real treat for me to be here with you today. I can't tell you how honored I am to have been here. I thought your questions and your insights were incredible. You guys are on the cutting edge, and it's my belief, as well as the audience, that you guys are the future of onshoring manufacturing back here in the United States. So I want to thank each and every one of you for today, and I look forward to being able to interview you and being your host again in another future session. Thank you.
Absolutely. Thank you so much.
Appreciate it.
Definitely our pleasure to be here.
Appreciate it. Thank you.
It's a pleasure, John. Thank you.
My pleasure.